Hello, today we'll be tackling to understand one of the more complex topics in statistics, the Latin square design. What does Sudoku, engineering, and statistics have in common? You probably already guessed it by now, but it's the Latin square design. What is the Latin square design? The Latin square design is a technique that its main purpose is to control experimental p-values into groups in such a way that the additional p-values do not affect the ones of interest. What are the flaws in the method? As Superman's biggest flaw is not being immune to kryptonite, we can say that the Latin square design's kryptonite is that it needs to have the same number of rows and columns for it to work. Why use the Latin square design? Because you can separate the p-values in different rows and columns in such a way you can isolate the wanted values. This makes it a very useful tool for researchers because of the way it lets them study variables when isolating. When do we as engineers use this method? No, not when we're thinking of food or empanadas in particular, even though they're really good. We use it as engineers when we know what we are testing. For example, if we wanted to test a new motor but only have 3 attempts and 3 different types of fuels to see how it affects it, but there's only three tries to attempt this. This makes it really useful because when you're doing the 3 attempts, you can isolate the motor's reaction in all 3 grids to see how it affected it in all 3 attempts. All right. I see my little friend Squirtle here is telling me that we're going a little too fast and this is a little too complicated. Let's see it in a simple example. Let's say you have 3 rows and this is a 3 by 3 grid. In this example, we are studying the threes because in each row we actually isolate it, and that way no three is affecting any other three, but at the same time we can individually study it when comparing it with the other variables. A very useful example of the Latin square design is in agriculture, because when cultivating different types of fruits and vegetables, they are separated in a way that one plant's consumption of a vitamin and mineral does not affect the one next to it, and later when cultivated, they are changed so the soil can regain the lost nutrients and vitamins while still cultivating other plants. In conclusion, we saw that it is a useful tool to test experimental p-values without each value affecting the other. We also saw some examples of this, including in both engineering and agriculture, and we can also conclude Superman's weakness is the kryptonite.